Alrighty, today we're doing 11.1, which is radical expressions and rational exponents. So we are going to start by rewriting these in exponential notation. So you can see these are all radicals, and we kind of had a preview of this yesterday, but we were going the other way. So the rule in math is that if you have, we'll call this x, and then if it's raised to some power, or if the power, hold on, we're not there yet, is underneath, and then you have the root, we'll call this r for root, sure, works for me, that you can rewrite this from radical notation and exponential by doing the power over the root. Power is on the top, the roots are on the bottom. People in power on the top, roots of a tree are on the bottom. And even this one, when the P is in the inside, the power, it's still the same thing. Okay? So let's go ahead and try these guys right here. So if it doesn't have an exponent, we're going to give it one. So we have the base is x, the power is 1, and the root is 3. Okay? Moving on to this one right here. Because these two things both have a power of 1 and they're both under the parentheses, we're going to write this as AB. We know the root is 4, and then it's to the first power. Okay? Let's try this guy. The base is 8, the root is 5, the power is 2. Moving right along. Now with this one, we just have to be a little bit careful. So you might always just want to put that in parentheses, and then we'll go from there. So this is 2x to the 5th, and all of that is raised to the first power, and the root is 6. And then, if we want, we can shower the power. So we get 2 to the 1/6, and x to the, be careful, multiplying fractions, no big problem, top times top over bottom times bottom. So technically both of these are correct. So then let's move on to the next one. Power over root, come on, power over root. We're plugging along. Okay, this is to the 5th power. We're going to leave it in parentheses because that 5 goes to both, and put it to the 5/6. Could you shower the power? Yes, but in this case it's not really necessary because they don't have different powers. This is still a perfectly good answer up here. But if we were asked to continue the problem and to simplify further, we might need to do something like that later. And then this one, we have ABC power over root. So ABC to the 4/5. Sweet! Now we're moving on to radical notation. So we're just doing the opposite now. So we're going from exponential to radical. Okay? So we need to write our radical. So the power is 2 and the root is 3. So this is a cube root, that's x. And then what's the power? 2. So for now we're just going to stick that 2 inside there. Okay? I told you before you can write it either way, but right now we're just going to leave it like that. And this is bothering me, so I have to erase this parenthesis because it doesn't have one, and I didn't put one on the other side. Okay, moving on to B. Oh my gosh, it's all letters, but we're good with it because we know the pattern. Y is the base, it goes underneath. P is the root because it's on the bottom of the fraction, just like roots are on the bottom of trees, and then raised to the n power. Okay, next one we have the base of 7, the root of 5, and it's raised to the 2nd power. So now we can actually write this as the 5th root of 49. So you would say the 5th root of 49 for that one. Alright, now we're going to just need to be a little tiny bit careful here because we have this guy right here. The 2 doesn't have that. That's actually to a power of 2, so it doesn't go under the root. So this is going to be x to the 4th. It's going to be the 7th root of x to the 4th. One thing I just want to point out to you guys real quick is that another way to look at this is 2 and then times x to the 4th, sorry, I was going to write something I wasn't thinking, all raised to the 1/7 power. And the reason that I'm writing it like this, and then our answer is still going to be the same thing as we got over here, is I want you guys to realize that this right here, the 1/7, would be a 7th root. Okay, so if it said 1/2, that would be a square root. If it said 1/3, it would be a cube root. Okay, now let's be really careful here. This 3/4, oh, this is what I'm thinking right away. This is AB cubed, because the power is 3 raised to the 1/4. So again, I know we know the shortcut, so we don't always have to do it this way, but I want you to think of that as a 4th root. The A doesn't need the root because it's to the 1st power, so the 4th root of B cubed. Alrighty? Alright, and then we're moving on to numbers. Yay, we love it when they have numbers in it. So it says translate the radical expression into any expression without or with rational exponents. Simplify if necessary. So the old school way of doing this is we could break this up 2 by 2s, you know, get 4 of a kind and see what our answer is, but we have a better way to do this now. So the better way to do this now is we see that this is all going to be 2 to the 12 over 4, because it's power over root, which is equal to 2 to the 3rd power, which is equal to 8. Okay? So we have that. Let's move on to the next one. Alright, so if in math, this is something that students don't understand sometimes, or they forget, this is a square root. There's a 2 here. Mathematicians are lazy. The most common root we use in math, and the most common root you guys use in math, is a square root. So mathematicians in their laziness are like, well, if it's the one we use the most often, rather than having to write that tiny 2 every time, we'll just say, if there's no number written there, it's a square root. It's the same reason why it's like, okay, well, if there's an x there, do we need to put a 1x in there? No, it's implied. So there is a 2 here, so 7, and then we have power over root, which is equal to 7 squared, and 7 times 7 is 49. Okay, next one, let's see, 2 to the 15th, the cube root of 2 to the 15th, so base, power, root, so that's 2 to the 5th power, which is 32. So if you're wondering how I know what 2 to the 5th power is, like I've been doing math forever, so it's not a big deal, but you don't need a calculator for this. You can do this in your head. So you have 2 times 2 is 4, times another 2 is 8, times another 2 is 16, and times the final 2 is 32. Okay? So don't sell yourself short. You can do this. All right. Base of 5, power of 10, and a 5th root. So a root of 5. So then we get 5 squared, which equals 25. Alrighty? Alright, so the next thing we're going to do is we're going to translate the expression with rational exponents into a radical expression. So we're just going the other way and then simplify if necessary. So we saw a little preview of these, we saw a little preview of these the other day. So this is 4 to the 3 halves power. So what this is saying is you are the square root of 4 and then raised to the 3rd power. Okay, so what is the square root of 4? That's 2. That simplifies to 2, but we still have the cube there, so that's 8. Okay, next one, 25 to the 1/2. This is one where you're kind of training your brain right now. 25 to the 1/2, anything to the 1/2 power is a square root, because it's power 25 to the 1st power, and we have right here square root. Okay, so I could even write it like this, but it's still a square root. Or better yet, over here on this guy, I could write 4 to the 3 halves as 4 to the 1/2 times 3. So I like you guys to see, I know right now this is the easier way, but we might be going somewhere where if we can see it like this, it's going to make our life like 10 times easier. So that's why I want you guys to see that this and this are the same thing, because when we have power to a power, we multiply the exponents. And 1 over 3 is 3, and 2 over 1 is 2, so we can reverse that too. We wouldn't need to reverse this one here because it's just a 1 as the power, so the square root of 25 is 5. Okay, so I'm going to try and separate this again just because we might be going somewhere where we need to be a little bit more creative with how we split this up. So the way I'm splitting it up is I'm saying, okay, this would be to the 1/3, and then I take care of the power, which is the 2 right there. Or we can just see it as the cube root of negative 125, and that whole thing gets squared, which is exactly what we have from one step. So some of you might be able to skip this step, but again, retaining this information and seeing this knowledge that 2/3 can be split into 1/3 times 2 is important. Negative 125, 3 of a kind out of that is negative 5, because negative 5 times negative 5 times negative 5 is negative 125, but then I got to square it, so that equals positive 25, because it's negative 5 times negative 5. If you don't put the parentheses on that, you are wrong. Okay, 6 to the 2/9. So let's see, we have the base, the exponent, and the root. So here's the deal. Can we take 9 out of a kind out of 6? Is there any number? The answer is no. So instead of writing it like this, another way we could write it, which we talked about before at the very beginning, you can either put the power on the outside or the power on the inside. We could write it like this, and then the only other thing we can do to simplify that is to do the 6 squared. Can I get 9 of a kind out of 36? Still no, because think about this, guys. If 2 to the 5th power is 32, and 2 is such a small number, there's no way we're going to get that to be a nice whole number. Whoa, look at this guy here. Okay, so let's follow along. So it's negative, but in order of operations, we always take care of exponents first. So that's what I'm going to do. So this is the 5th root of, let's see, 243 over 32. And then whatever's in parentheses, because the negative is not, is raised to the 4th power. Well, there's a rule in math that says if you have a fraction under a radical, you can split each numerator and denominator into the radical. So you can do that. And can I get 5 of a kind out of 243? So you guys don't know this because you haven't practiced. Maybe actually you do. So the 5th root of 243 is 3, and the 5th root of 32 is 2. So I got 5 of a kind, that's 2 times 2 times 2 times 2, and then 5 of a kind there is 3 times 3 times 3 times 3 times 3. And this is still raised to the 4th power. So I get, let's go up here, I get negative, and then I get 3 to the 4th power over 2 to the 4th power, which is negative 81 over 16. And I don't need the parentheses anymore because it is going to be negative. I just wanted to be really careful there in the beginning. Alright, 81 to the 3/4. So let's do that one. So we have 81, the 4th root, and then we're going to cube it. 4 of a kind out of 81, you might be like, I have no idea, but you do know 9 times 9, and then you have 3 times 3 times 3 times 3. So there's my 4 of a kind. So the 4th root of 81 is 3, but then I still have that 3 out there, so it's 3 cubed, which means that this is going to be 27. Alrighty, so that is the lesson for today. Sweet.